Next, what if pH of a solution is given, but you are asked to identify the hydrogen concentration instead? Basically, the opposite of what you've been doing so far. Okay, the formula for that is 10 to the power of negative pH, or you can also say it as shift log negative pH, because the calculator function would be shift log negative pH. Okay, so let's look at an example. Concentration of hydrogen ion in a solution with a pH of 3. Okay, so all you have to do is, to get this power 10 to the power of, you click shift log. Shift log would give you this tiny little function here, the one that is in yellow. Okay, shift log negative 3, because the pH is 3. You would get 1 times 10 to the power of negative 3 mole per liter. Okay, so a solution with a pH of 3 has 1 times 10 to the power of 3 mole per liter of hydrogen ions. Next, what if the concentration of hydrogen ion is not given, but you are required to calculate pH from hydroxide ions instead? Okay, the first step would be to find the concentration of hydroxide ions. So for this question, 0.02 mole per liter of barium hydroxide solution, identify the concentration of hydroxide ions. Okay, remember, barium hydroxide has 2 moles of hydroxides. For every 1 mole of barium hydroxide, there are 2 mole of hydroxide ions. So if I were to have 0.02 mole per liter of barium hydroxide, if the volume is constant, 0.04 mole per liter of hydroxide ion will be present. Okay, so this is the concentration of the hydroxide ion. Now, since you are still going to find the pH, you are required to find the concentration of hydrogen ion from this information given. How do you do that? Remember your water ionization constant. Water ionization constant is basically concentration of hydrogen ion multiplied by concentration of hydroxide ions. So you have to remember Kw is 10 to the power of negative 14. You rearrange this equation to something that looks like this, okay, because you want to find the concentration of hydrogen ion. Okay, so you'll end up with water ionization constant divided by hydroxide ions. Okay, so the value for water ionization constant is 10 to the power of negative 14. The value for the concentration of hydroxide ion is 0.04. So the concentration of hydrogen ion is 2.5 times 10 to the power of negative 13 mole per liter. Okay, remember, to find out the pH of a basic solution, to find out a pH of a solution where only hydroxide ion is given, first identify the concentration of hydroxide ion and find out the concentration of hydrogen ion using this equation. Put in the values, water ionization constant divided by the concentration of hydroxide ion. The third step is basically finding the pH. Since you have already gotten your concentration of hydrogen ion, from now on it should be easy. It's basically negative log concentration of hydrogen ion, and the value is 12.6. Okay. Next question. If the pH of sodium hydroxide solution was 9.5, what was the concentration of the solution? Okay, so many things here you need to know. Again, pH is given, concentration of the solution is what you need to find. Okay, so first step, find the concentration of hydrogen ion. Why do I say that? Because the only information that was given in the question was the pH. So you'll have to work from there. Okay, so how do you find the concentration of hydrogen ion from pH? Use this formula. Hydrogen ion concentration is equals to 10 to the power of negative pH. In this case, the pH is 9.5. So 10 to the power of negative 9.5 is 3.162 times 10 to the power of negative 10 molar or mole per liter. Next step. From the concentration of hydrogen ions, you can get your concentration of hydroxide ion. The key here is again the water ionization constant. You rearrange the equation so that you get your hydrogen ion concentration here and your hydroxide ion here, since this is what you want to find out. Okay, so 10 to the power of negative 14 divided by 3.162 times 10 to the power of negative 10, which is the concentration of the hydrogen ions, and you will get your concentration of hydroxide ions. Okay, remember the question is asking for the concentration of the solution, not the concentration of the hydroxide ion. But since sodium hydroxide, okay, completely dissociates into sodium ion and hydroxide ion, and for every 1 mole I get 1 mole. Okay, so basically the concentration of hydroxide will be equal to concentration of sodium hydroxide. Okay, because remember when they say the concentration of the solution, they mean the concentration of sodium hydroxide, not just hydroxide. Okay, so make sure you know the difference. So the concentration of the sodium hydroxide solution is 3.16 times 10 to the power of negative 5 mole per liter. Think about this. Why do pH calculations only involve strong acids and bases with concentration less than 0.1 molar? If you've seen the examples before, all the examples involves strong acids and bases and the concentrations are all less than 0.1 molar. So think about this and we can discuss this in class.